This content is on reliability and validity, and these are two essential standards of good measurement tools and, in fact, of good research. This material is in Chapter 6 in your Adams text. So, in our last chapter, we talked about different ways of measuring your dependent variable, like observation and self-report and proxy measures and so forth. But regardless of what measurement type you're using, it has to be reliable and valid. So what do we mean by this? So first off, reliability versus validity. In an experiment, you need to pay attention to many things. Two of the most important ones are reliability and validity. Your experiment and your measure needs to be both reliable and valid in order for it to make sense and provide you with quality results. So reliability is the extent to which the outcomes are consistent when the experiment is repeated more than once or when the measurement tool is repeated more than once. Validity is the extent to which the instruments that are used in your experiment measure exactly what you want them to measure. So let's tease these out a little bit. So reliability means that the measure is consistent. And so you can see here, they're shooting for this target right in the middle. But none of their pins hit the middle, which suggests it's not valid. It's not measuring what it's supposed to measure. However, all of the pins hit at this level, right here, very close to each other, which suggests that it is, in fact, reliable. In the second example, target B, we have none of the pins hitting the target and none of them anywhere near the other ones. And so we have a measure that doesn't have validity because they're not in the center, and it's not reliable because the results are all over the place. In target C, we have good validity and good reliability, meaning that the measure seems to be hitting the target, measuring what it's supposed to measure, and that the pins are all near to each other, so it's reliable, consistent. So let's look more at reliability. Here we have a scale, and this person is standing on it, and the first time it produces the weight 150 pounds, and the next day it produces the weight 225 pounds, the next day 128 pounds, the next day 176 pounds, and imagine that this person is actually about 155. Now in this case, we do not have a reliable measure. We know that a person's weight could not in fact fluctuate this much across days and across just a few days. And so the measure isn't reliable, and it's likely not valid either. So the reliability of a measure is the consistency of scores produced by the measure. So we'll talk about a couple of types of reliability checks, three actually, two on this slide and one on the next. Internal consistency is one type. And what that means is a person responds similarly on similar items within the measure. So if this is a self-report questionnaire, they would produce similar responses to the statement, I enjoy cooking, and cooking gives me pleasure. If they didn't, if we weren't getting similar results on these items that are very similar, then we might have poor internal consistency in this measure, which we would deem to be unreliable. Secondly, we want to have test-retest reliability. It means that we will produce similar results over time. So if the measure was taken again at a later time, would the result they produced be similar? Thirdly, we have something called inter-rater reliability. Two different raters are trained to observe the same behavior. So you can see these two observers observing something, and we really want their results to be similar. So if we've trained these two observers well, they're going to be observing the same things because they're looking for the same things. And the example that I gave you earlier in the last lecture, in the strange situation task, raters are trained to observe very specific facial expressions linked to infant emotion. And so we would want to make sure that they're rating them in the same way. Validity is how well does a test measure what it's supposed to be measuring. And this person, again, we have standing on the scale, and each time they get on the scale, it's telling them they weigh 9 pounds, 9 pounds, 9 pounds, 9 pounds. And we know that's not possible for an adult human being, unless they're out in space or something like that. So we see a measure here that's reliable. It's producing the same result. It's consistent, but it is not valid. It's not giving a measure of what it's supposed to measure, which is weight in pounds. So we have several types of validity, and the first of these is construct validity. And in our lecture on operationalization, we discussed what constructs were, and we know that they are combinations of ideas that can't be measured with anything physical. So the examples, the concepts of intelligence and motivation, both of these are variables that are used to explain phenomena in psychology, but we can't really observe them. We can't put a thermometer in, we have to have some sort of a scale to measure something that's just in our own minds. These are concepts that are in our own minds, and they're called constructs. So when we're measuring a construct, it's an idea that's just in our own mind, it's not observable, and we're trying to measure it and make sure our measure is actually measuring what we want it to measure. Content validity asks whether the tool measures the content it's supposed to assess. So usually this refers to testing like in the school. So the content is the material that's being learned or taught, and usually referred to in academic testing. An example here, does the ACT really measure one's capacity to perform well in college? Does the test measure what was taught or what was expected to be learned? And that's content validity, meaning, is what we taught you, have you actually learned it? So very often in psychology, we're trying to validate constructs. And there are 4 types of construct validation that we can do. And remember, this is just demonstrating that our scale or our tool measures what it's supposed to measure. So convergent validation is the first. Does the scale or test produce results that correlate positively with related constructs? So this might not make sense to you till you look at the example. So example, imagine that we are trying to measure general anxiety. We've developed a scale. What we would expect if someone has a lot of general anxiety, if they're high, is that they would also have high scores on similar scales, like tendency to worry would also be kind of high, and neuroticism would also be kind of high. If they have high scores on our new general anxiety scale, but they produce middle or low scores on tendency to worry, something might seem off, because it seems likely that they would also be a little higher on the tendency to worry scale. Divergent validation is the opposite. Does the test produce results that correlate negatively with unrelated constructs? So for example, going back to our scale for general anxiety, we would expect that it would correlate inversely with social ease. So social ease is just being really comfortable, easy in social situations. And if someone has high scores on general anxiety, we'd sort of expect that they would have lower scores on this social easiness measure. If they didn't, if they had high scores on our new scale of general anxiety and high scores on social ease, we might say something seems not right here. Discriminant validation. Can the measure distinguish those who are very high in a trait from those who are also high but not quite as high? And so that might seem odd to you the way it's written, but what you're trying to do is discriminate a new construct. So if we think our general anxiety scale is measuring a brand new construct that's just not quite measured in any other way, well then we want to have our scores, have individual scores on our general anxiety scale be similar to tendency to worry, but not identical. If our scores on our new general anxiety scale are identical, then it might be that there's no difference between our scale and tendency to worry, or in other words, our scale for general anxiety doesn't discriminate between this trait, general anxiety, and the trait tendency to worry. So we have to adjust our scale. And finally, and this is the best I think, it's criterion-related validation. Does the scale produce a relevant outcome? Does it predict what's happening in real life? So we would expect that if our scale on general anxiety is a good scale, we would see other indicators in people's lives. Maybe they would tend to self-medicate. Maybe we see higher rates of self-medication through drugs or alcohol or other means. Or maybe we'd see that people who score high in our general anxiety scale also have a lot of trouble relaxing. And that's criterion-related validation, meaning does the scale meet behavioral criteria? So here is an example we'll work through. We're interested in predicting which people are likely to explode in anger and possibly harm others. We think it's important because we have people who have this kind of rage inside them and cause harm to other people. And if we can predict, maybe we can help. And so we're going to call this trait that we're interested in volatility and define it as a measure of likelihood of explosive emotional reactions, volatility. So we're trying to make a scale, and we're going to test items for this new scale and test it with a wide range of people. And maybe it would be, one item would be, I often feel a deep inner rage. Another item might be, I often want to punch or hit something when I am angry. Another item might be, other people want to cause me harm. A little bit different, but maybe this all gets at volatility, and so on. So now we've developed our measure, and we need to validate it to make sure it's useful and measure what it's supposed to measure. So here's our volatility. What traits or behaviors might we use to predict an individual's level of volatility? Well, if this is what we are having as traits that are related, we have someone who's very impulsive maybe high in loneliness, maybe not a very agreeable person, low in agreeableness, and maybe high in hostility. So our construct volatility consists of these characteristics. All right, and so we have circles so you can see them all. And so then what would we expect? All right, for our convergent validation, we would expect that volatility, our new measure, correlates positively with loneliness, so that one individual, say this individual, produces a score that's high in volatility and high in loneliness. And so this person who's low in volatility, also low in loneliness. So we would expect a positive correlation. Similarly, we would expect a negative correlation between volatility and agreeableness. And so if someone is high in volatility, way up here, we might expect them to be low in agreeableness. And so this person has a very high volatility score and a low agreeableness score. This person has a high agreeableness score and a low volatility score. And so this first is an example of convergent validation, and this is an example of divergent validation. And so loneliness and volatility walk together. High scores on one, high scores on the other. Agreeableness and volatility go in opposite directions. As volatility goes up, agreeableness goes down in terms of our numbers. And so there's a little more examples. If two scales are expected to produce similar results, and they do, they have strong convergent validation. If two scales are expected to produce dissimilar results, and they do, they have strong divergent validation. All right. We also have criterion-related validation. And so if we say that volatility actually measures something in real life, then we might expect that really highly volatile adolescents get suspended from school more. So as volatility goes up, the number of suspensions a person has goes up, and you know that each of these dots represents an individual. Likewise, we would expect that these adolescents who are highly volatile aren't really joining clubs in school activities. So as volatility goes up, club memberships go down. So here's a person who belongs to a lot of clubs, and they're not really volatile, right? They're low on volatility, high in club membership. Now, if we got a result that perfectly predicted one variable from the other, that means that we don't have a good measure of volatility. So we have poor discriminant validity. And of course, then there's the real life test. If what we're really interested in is predicting adolescents who are likely to cause harm to another person through violence, that's the ultimate criterion test for our measure of volatility. And if we know about it, maybe we can prevent it. So a question, what if the tool that we're interested in using, that you're interested in using for your dependent measure isn't a scale, but it's an observation or a proxy measure? Do those have to be reliable and valid? And the answer is yes, they definitely have to be valid and reliable. So valid. In some way, if you're using a tool like the aggression tool, then if we're using an aggression tool, then we have to ensure that this blast of loud noise, does that really correlate with feelings of aggression? So we have to validate that measure by kind of testing it. What we might do if we're using that measure is we might, after the study, ask people to report how aggressive they felt at that time. And we would expect that self-report to correlate with the length and volume of the noise they made. And reliable, we must ensure that the scale produces reliable, consistent results across individuals when they're feeling aggressive. So we want to know whether people will behave aggressively when provoked. Then we have to measure aggression consistently in aggression-provoking situations. So does our tool consistently, this loud blast, does it consistently measure aggression in those situations where someone might be behaving aggressively? So the final word, a tool can be reliable but not valid. So it can produce consistent results but not really get at the construct of interest. But a tool cannot be valid unless it is reliable. So if we have an unreliable measure that doesn't produce consistent results, then we don't have a tool that is useful or valid either. So keep thinking about your dependent variable and how you need to make sure that your measure is going to be valid and reliable. And we'll come forward, we'll talk about how we also want to make sure that the experiment itself is reliable, but that's for another time. Thanks for tuning in.